Meet Mr. Rudolph, a friendly man with a small but puzzling problem. One of the panels on his wooden wall has mysteriously gone missing. At first, Mr. Rudolph was stumped, but then he remembered he had a few extra wooden pieces stored away. Maybe, just maybe, they could help him fix the missing region. From what he could recall, the first wooden piece was a perfect square with an unknown side length. The second was a rectangular piece, 10 centimeters wide, with its length matching the side length of the square piece. The third piece was another rectangle, this time 7 centimeters wide and 5 centimeters long. Mr. Rudolph had all the tools he needed to get the job done. Well, except a proper measuring tool, but he did have his trusty 5 centimeter stick. It wasn't perfect, but it might just do the trick. Before he could begin, Mr. Rudolph decided to use the stick to measure the side length of the missing panel. He tried measuring a side of the missing panel stick by stick, but the stick just wasn't long enough. However, when he placed the square wooden piece into the remaining part that the stick couldn't reach, it fit perfectly, edge to edge. This meant the missing panel had one side of length, x plus 5 centimeters. He repeated the process on the other sides and discovered that all the side lengths were the same. This meant that the missing panel was a perfect square with a side length of x plus 5 centimeters. Now, here comes the real question. How could Mr. Rudolph use these wooden pieces to form a new square that perfectly fits this missing region using the information given? There might be many ways to solve this problem, but before we look at one way of solving it, I'd really appreciate it if you could comment your thoughts, and if you'd like to see more content like this, you could possibly help us out by subscribing. With the assumption that you've done that, let's now take a look at one way Mr. Rudolph can solve his problem. Let's start by listing out what we know. He has a square piece with side length x centimeters. He has a rectangle that is 10 centimeters wide and x centimeters long. He has another rectangle that is 5 centimeters long and 7 centimeters wide. He used the square wooden piece to measure part of the missing panel and found that portion to be x centimeters. Then he used the stick to measure the remaining part, which turned out to be 5 centimeters. So, he can start by placing the square wooden piece right here, since he already knows it's a perfect fit. Next, he takes the rectangular piece, which has the same length as the square piece, x centimeters, and a width of 10 centimeters. Using his trusty stick, he measures 5 centimeters from one end, allowing him to split the rectangular piece into two smaller rectangles, one 5 centimeters wide, the other also 5 centimeters wide. He then takes one of these 5 centimeter wide pieces and places it right here. Now, since he already knows this part measures x centimeters, and the full side length of the missing panel is x plus 5 centimeters, he can take the other half of the split rectangle and place it here. This gives us an L shape, essentially a corner of the square we're trying to build. With that, he would have outlined two sides of the square. All that's left is to fill in the missing corner to complete the square. That leads Mr. Rudolph to the question of what must be added to this L shape to make it a perfect square. Well, that's not so hard. If you observe closely, you'll notice that the missing piece must have a width of 5 centimeters and a length of 5 centimeters. That is, it must be a square with an area of 25 square centimeters. And thankfully, he can get exactly that from the remaining rectangle by measuring with the stick. And from this remaining piece, well, let's just say Mr. Rudolph can toss it back into the store. No need for it now. With that, the square is complete. And Mr. Rudolph's missing panel is all patched up. And this technique of fitting the square is actually called completing the square. Many of you might be familiar with this technique when you're given a quadratic expression and asked what must be added to make it a perfect square. You might be wondering how we can get a quadratic expression in our case. Well, we can get that by looking at the areas of the pieces. The first wooden piece has a side length of x, which means its area is x squared. The second piece has a width of 10 centimeters and a length of x centimeters, so its area is 10x. So when you're given an expression like x squared plus 10x and asked, what must be added to make this a perfect square? It's really just asking if you are building a square using pieces with those exact areas, what extra piece would you need to complete it? So the approach involves trying to first construct a square by using the areas of the rectangles given, which you can do by splitting the rectangle with area 10x into 2 and placing them this way to form a corner with equal side lengths, setting up a perfect square. And that leads us to a missing piece with width 10 divided by 2 centimeters and length 10 divided by 2 centimeters, forming a square with area 10 divided by 2 all squared, which is equal to 25. So hopefully that helps you understand why we divide the coefficient of x by 2 and then square it. Now, let's say Mr. Rudolph wants to find the value of x. He discovers another wooden piece with an area of 11 square centimeters. And he remembers that this area is actually equal to the combined area of the two earlier pieces, the square with area x squared and the rectangle with area 10x. That means x squared plus 10x equals 11. Now say Mr. Rudolph doesn't quite remember how to solve an equation like this. What he can do is use the completing the square method. He can think of forming a square using these two areas and then comparing the side lengths, because squares with the same area must have the same side length. So if he tries to form squares using the areas, he'll get this. And earlier we learned that a square of 25 square centimeters must be added to make the area x squared plus 10x a perfect square, leading us to a square of area x plus 5 squared. If we decide to add that same square of area 25 square centimeters to the other side, we get a square of area 36 square centimeters. Now, since these two squares will have equal areas, it must mean their side length must also be equal. That is, x plus 5 equals 6, which means x equals 1. This method of comparing the side lengths of squares with equal areas is basically what you do when solving a quadratic equation using the completing the square method.